Alright, ladies and gents, today we're going to be talking about 4.1. We're going to be talking about classifying triangles. There are quite a few notes in this one, so buckle up. So when we look at triangles, we know a triangle has three sides. The one thing we also know about triangles, it can be classified in two different ways. We look at their angle measures for classification, and we look at their side lengths for classification. So there's going to be different ways to classify each triangle. You may know some, you may know them all. That's great. A little review never hurts. The first classification that we have here is going to be by angle measures, as you can see at the very top. We know that if we have three acute angles on a triangle, it is going to be known as an acute triangle. Three acute angles means it is an acute triangle. That's number one. Second one that deals with angle measures, we're talking about three congruent acute angles. Even though they are acute angles, these are three congruent, and it's got a special name, and it's called equiangular. Okay, equiangular triangle. So three congruent acute angles means that it is going to be an equiangular triangle. So if I asked you what would those degree measures be, well, we know that a triangle adds up to equal 180 degrees, so each angle would have to be 60 degrees in order for it to be an equiangular triangle. So if you know that those three are 60, it is an equiangular triangle. Next one. It is a right angle. Notice it has a right angle. That's the box down in that bottom left-hand corner of that triangle. Because it has a right triangle, it's got a special name called the right triangle. All because of that right angle. That right angle means a lot for this type of a triangle because it's named after the right angle. It's a right triangle. Awesome. One more classification by angle measures. That is the obtuse triangle right there. Obtuse triangle. And we know it is an obtuse triangle because we have one obtuse angle. Okay, so those are your four classified triangle names. Okay, first one, you have your acute angle, or acute triangle, because it has three acute angles. Next one, you have your equiangular triangle. Even though it has three acute angles, all three angles are congruent. Then you have your right triangle. Easy one there. Right angle means it's a right triangle. And last one, obtuse triangle. Obtuse angle, obtuse triangle. Awesome. So we're going to work on classifying them. So if I look at this triangle, actually there's several triangles here. You don't have to write this down. I'm just going to go over it. I'm going to look at BDC. So BDC. Okay, if I look at BDC, I'm looking at angle measures. So that 100's right there, this 10 is right on the inside, and the last one, well, it doesn't give us it. Okay, so now we have 100, we have 10, and that's all I need to know. Why? Because this angle is the one that gives it away. It is an obtuse triangle, an obtuse angle, which means we have an obtuse triangle. Because we know one angle is obtuse. That's all we need to know. If we know one angle is obtuse, that means the entire triangle is an obtuse triangle. Excellent. So please draw this one because this is for your notes. And I want you to give this one a shot. You know the four classification by angle measures for triangles. It's either going to be acute, equiangular, right, or obtuse. Give this one a shot for ABD. ABD. All right, so we have an ABD triangle, and that's this small one right here. ABD triangle. So we have an 80-degree triangle. We have a 20-degree triangle. Well, what do you think this corner right here would be? Well, we know that a triangle adds up to equal 180 degrees. If we take 180 minus 80, we get 100 minus another 20, we get 80 again. So this angle right here is 80 degrees. That means we have an 80-degree angle 80-degree angle, 20-degree angle. 3, I repeat, 3 acute angles. Because we have 3 acute angles, it is an acute triangle. So cute! It's an acute triangle. It's so cute because they're so little. Yes, awesome. Okay, FHG by its angle measures. Give this one a shot, see how you do. Awesome. Hopefully you notice that this is 60, because we're looking at this triangle right here, 60, 60, which means the third angle has to be 60 degrees. We have 3 60-degree angles, which means they are all congruent, 3 congruent acute angles. This is an equiangular triangle. Awesome. Awesome, awesome, awesome. Okay, now we're going to get into classifications by side lengths. So this very first one, we talked about 3 congruent angles. This time we're going to be talking about 3 congruent sides. Something I believe you have heard before. This is known as equilateral. Equilateral triangle. Okay. When it is equilateral, all the sides are the exact same measure. Exact same measure, equilateral. Awesome. Let's move on to the next one. This next one, at least 2 congruent sides. When we have 2 congruent sides, at least 2 congruent sides of a triangle, we are going to be talking about an isosceles. This is known as an isosceles triangle. 2 congruent sides is going to be an isosceles triangle. All right, moving on. The last one is going to be no congruent sides. If a triangle has absolutely no congruent sides, none whatsoever, zilch, 0, it is known as a scalene triangle. Scalene triangle is going to be no congruent sides. No congruent sides, scalene. Scalene, no congruent sides. Okay, that means nothing is equal. All right, so we have 3 classifications for side lengths. We have scalene, we have isosceles, we have equilateral. Let's see how we do with this. Okay, it says when you look at a figure, you cannot assume segments are congruent based on appearance. They must be marked as congruent. Do not assume anything in math. Don't assume, don't assume, don't assume. Guess what you can't do? You can't assume, okay? If you are given those marked as a congruent, remember, your markings are those little tick marks, okay? If they have those little tick marks, then you know they are congruent for sure. You can't just look at it and assume, it looks pretty close. No, it doesn't work that way, okay? If it doesn't have a tick mark, it is not congruent, all right? Let's try one. So if I look at this, classifying EHF, I'm going to look at EHF. Okay, looking at this, I notice I have 2 congruent marks. Don't look at anything else. I'm looking at those two congruent marks. Even though they might appear to be similar on the other sides, they are not because they don't have those marks. 2 congruent sides means it is what type of a triangle? Isosceles. 2 congruent sides. Sweet. Next one. Please write this one down by its side lengths. Okay, EHG. We're looking at this EHG. All right, so when we look at the overall side lengths, okay, we have 12 as EH, we have 11 as HG. Then what is EG? We would need to add these 2 together to get 15. So we have 12, 11, 15. We have 3 different side lengths. None of them are the exact same. So we have a scalene triangle because none of them are the same. So a scalene triangle. Questions? Concerns? Awesome. Moving on. Flying through this. We're flying through it, yet we're having fun. Okay, now we're looking at an ACD triangle. ACD. Good band. ACD. Measure this one by its side lengths again. Side lengths. All right. So we look at this. As you're looking at this, you know what AD is. Okay, AD is 18. Has a measure of 18 degrees. We know what CD is. Has a measure of 5. But we don't know what AC is right off the bat. It doesn't give us that measure. However, what does it give us? Yeah, it gives us these little tick marks, which means something is congruent. All right, so what's congruent? Well, AC is congruent to AB. What's AB? It's 15. So now we have a 15, 18, and 5. Well, when we have 15, 18, and 5, what type of triangle is this? You got it. It is going to be another scalene triangle. What makes it a scalene triangle? No congruent sides. No congruent sides. Scalene. Awesome. Okay. Here's when we look at the different vertices, you don't have to write this down, and the different sides, AB, BC, and AC are known as the sides of the triangle of ABC, and A, B, and C are the vertices. Okay? Easy as that. AB, BC, and AC are the sides. A, B, and C are the vertices. Pretty simple. I want you to identify the side opposite of each angle. So identify the side opposite of each angle. So if I'm looking at A, what's opposite? If I'm looking at B, what's opposite? If I'm looking at C, what is opposite? So I want you to try those three. Okay? Angle A. What is opposite of angle A? Okay, I'm looking at the side opposite, and that's this way right there. Okay, so angle A is going to be BC. Side BC is opposite of angle A. If you look at angle B, we're looking for the opposite side. Opposite side is going to be side AC. Last but not least is angle C. We're looking for the opposite of angle C, which is AB. Opposite meaning on the other side of C. C going there, points out to the other side, AB. Awesome. Awesome, awesome, awesome. We are done for the day. Have fun. Enjoy. We'll see you tomorrow.